Since the beginning of the COVID-19 pandemic, car sales have plunged, but there has been a rise in production and circulation of electric vehicles, EVs. By 2040, it's estimated that 30% of cars on the road will be electric. When a petrol car is dismantled, as much as 95% of it is likely to be used again. Since the EV market is relatively new, this level of efficiency still hasn't been reached. Furthermore, EVs contain a greater variety of materials, especially in the battery, making them trickier to recycle. An electric battery is a device that transforms the chemical energy of an oxidation reaction into electrical energy. The car battery stores energy and sends it to the engine, where it's transformed into mechanical energy, used to turn the wheels that make the car move. Electrical batteries come in different types that vary in raw material composition. The most common are lithium-ion batteries and lead-acid batteries. Some of the raw materials used in the batteries are scarce. The batteries of electric cars have a life expectancy of 8 to 10 years, after which the battery has to be recycled or disposed of. At the end of the first life cycle, a battery can still run at 75% of its capacity, which is however not enough to power an EV. Used batteries can be given a second life by employing them in less burdensome tasks. Their most common use is energy storage for residential houses, street lights, and solar farms. A battery can also be remanufactured through direct recycling, which consists in the disassembly of the battery and the repair of its damaged parts, so that it can be restored and directly reused in vehicles. Or, the battery can be recycled. The two most common methods of recycling are pyrometallurgy and hydrometallurgy. Pyrometallurgy is based on pyrolysis. The components of the battery are melted into a metallic mixture called black mass, from which pure metals can be separated. This method requires a lot of energy and destroys valuable non-metallic components. Furthermore, lithium ends up in the slag and has to be extracted separately. Hydrometallurgy, on the other hand, shreds the materials and then separates the mixture into three: plastic, copper and aluminium, and black mass. The black mass is then dissolved into acids to leach the metals. This process requires less energy and also permits the recovery of non-metallic materials, but is more complex and comes with the added production of toxic wastewater that then has to be treated. In both cases, the extracted materials are almost pure and can be reused for the production of new batteries. Recycling methods are in constant evolution and could be made more efficient if batteries were designed and produced, keeping recycling in mind. The use of electric vehicles, their recycling, and a recycle-friendly design will contribute to a more sustainable mobility with less pollution, energy waste, and raw material waste.